Welcome, everyone. Thanks for joining us. This is the fourth community meeting of users of eLabFTW. I'm Sydney, the Customer Success and Community Manager, and I'm joined by Nicola, the lead developer and founder of eLab, along with our newest team member, Mustafa, who recently joined us as a full-stack developer. Hi.
Hello. Hi.
Yeah. So this is your first community meeting, Moose, and maybe some other people who are here too. So normally in the community meetings, we have presentations on topics that are relevant to users, such as how people are using eLab in their own lab. And this time we're also going to feature a talk about how to use one of the features of the software. So first we'll have a 15-minute presentation by Dr. Michael Krieger, who will discuss the use of eLabFTW in their physics lab course and who will introduce their pyelabdata package. And then after that, Nicola from Deltabot is going to demonstrate how to use the API to automatically retrieve and manipulate data in eLab. All right. Okay, Michael, take it away. And thanks so much for being here.
Yeah, thank you very much. Thanks a lot for the invitation and for this opportunity to present our use case. Now I will share my screen. So we are using eLabFTW in the physics lab course. And this will be more a live demo than a standard presentation. But before jumping into the live demo, I need to set the scene a little bit that you know what I'm talking about. So a few years ago, we got the insight that for modern physics, data literacy is as important as experimental skills that you acquire in lab courses, mathematics, which you acquire in courses, lectures, and so on, etc. So as a consequence, in Erlangen, we changed the physics curriculum a little bit, just a little bit, by introducing a mandatory programming course in Python in the first semester, which is German Datenverarbeitung in der Physik, so data processing in physics, where the students learn Python programming, Python scripting in Jupyter notebooks along physics examples. So they get some data, physics problems, and they try to solve this in a Jupyter notebook. They learn how to tweet the data and how to visualize data using Matplotlib, for example. And then we introduced electronic lab notebooks in the fourth semester. We have a lab course. This is actually electronics for physicists. And in this lab course, we introduced electronic lab notebooks. And that's the programming course in the first semester. This is an exceptional benefit for us because when you work with electronic lab notebooks, you have the data already in a digital form. So you want to treat the data also using Python, for example, for evaluation. And we can rely on the fact that our students are already experienced using Python for data evaluation and visualization. So before you start introducing an electronic lab notebook in your lab course, you have to ask yourself a lot of questions. So how should the ELN look like? Do you want to predefine all the experiments, or do you just want to provide templates as you would do, for example, in research when you use ELNs in research? Do you want all the data in the lab course to be structured? This means that you provide templates with fields where you explicitly put the voltage reading in this field and then the current reading in that field and so on. Or do you want to stay with unstructured data, which leaves also a lot of more freedom to the students in experimentation? So they really have to think about what reading is important and which value has to be stored in the lab notebook. Do you just want to use the ELN, or do you even want to define and configure data schemas as part of the lab course so that the students even learn how to configure templates and so on? Do you want just to document your experiments, or do you even want to create the full report of the lab course in the ELN? So that it all goes back to the question, how much do we want to optimize the ELN for the usage in teaching or for the use as a realistic ELN like you would do this in research. So our goals are as follows. We wanted to make the data management easier for the students. This is also because we didn't allocate additional time for introducing the ELN. We just said, okay, we get rid of the paper lab notebooks, and here's the electronic lab notebook. We didn't cancel any experiment and allocate time for introducing the ELN. So this is a requirement. A requirement is to make everything easier in order to save even time. We wanted to leave freedom in experimentation to the students, so we didn't go to the structured data approach, and the main goal was to train the students for ELN usage in research when it comes to bachelor or master thesis. So when you answered those questions, you have to think about the infrastructure, of course. You need a server, you need to install the software and so on. At the University of Erlangen-Nuremberg, we are in an extremely lucky situation that we have the FAU Competence Center for Research Data and Information, in short CDI, which is a central scientific center that provides services for research data management. So they operate the server hardware, they install the ELN software and maintain the software. They also provide the connectivity to other central university services like single sign-on. They take care on data backup and so on. And they provide support when it comes to using the services. In Erlangen, we have eLabFTW installed as a university-wide service, ELN service, in two flavors, one research installation and one teaching installation. Both are connected with the single sign-on and in backup. And the teaching instance of eLabFTW is free of charge for all members of the University of Erlangen-Nuremberg. You can simply log in with the university account, and then you can start using it. Okay, once you have the ELN in place, you have to configure it. And as I said, we wanted to provide very easy usage of the ELN. So we want to provide all the experiments pre-configured, but without forcing for the data structure. That requires that you need a script somehow that does the job, because you have to import all the users from your learning management platform, the students and the tutors. You have to create user groups in the lab course. In our lab course, it's they are working in teams of 2. You have to create the templates. You have to predefine the structure for the lab course days and experiments, assign the user access rights that the teams of 2 can access their shared electronic lab notebook. The tutors should also be able to read the lab notebooks of the students and so on. So this is done using a Python script which relies on eLabFTW's API, and I show the link here to the GitHub repository where I share this configuration script for setting up the eLabFTW for the lab course. Okay, and then let's have a look how it looks like from the student's view, let's say. So I will switch to the browser. Here you can see eLabFTW. I've filtered the experiments in the experiment overview for the group 98. This is my demo group. I have to apologize that all the captions and texts here are in German. This is because the lab course is in the bachelor studies, and that's a German course. But whenever it's necessary, I will translate that. As you can see, the configuration script creates a lot of experiments, actually all the experiments for the whole semester in advance. And you can see we have green objects and blue objects. We can filter for that, of course. The green objects are the lab course days. There are 10 in total during the semester. And that's kind of a navigation overview. When you go into such a lab course day, you can see all the experiments which have to be done at that specific day are linked to that object, so that the students can easily navigate. For example, this is experiment 1.2, and I want to do this experiment now and record the data. And then you can easily go back to the overview and continue with another experiment of that day. In addition, we store some metadata, so who is in that group, the group number in those extra fields. And as you can see, the group itself and the tutors, they are able to view this entry, and the group is able to modify the entry. Okay, let's go back and take a look into one of the experiments. So this is how it looks like when the students start with the experiment. We have predefined statuses where they can note that they have done the preparation work, they have done the experiment, or they are on the evaluation, and so on. In the main text, we have several sections where we ask the students in preparation of the experiment to write down a single sentence on the aim of the experiment. So what is the research question of this experiment? And then we provide some questions that they have to answer in preparation of the experiment. This will be placed here under Vorbereitung, so that's preparation. Experimental description they put here, and then they record the results, put it in that section, and during the evaluation they can make notes on how they treated the data in that section. So that's the documentation of the experiment, and of course you can upload files which might become necessary, and we predefined also some steps in this configuration script where they can check, okay, the preparation for this experiment I have done. So that gives the students a nice overview when they use the to-do list, where you can see, okay, here for the first experiment, I just have to do the evaluation and make sure that all data files are uploaded. But for example, for that experiment, I still have to do the preparation work and also have to do the experiment and so on. Okay, let's have a look into this experiment. 1.1, this is about the measurement of the shunt resistance of a digital multimeter. In this experiment, the students record data manually. So they have two instruments. They take the data readings from the instrument and put the data manually into such a table. That's in a lab course. That's one possible way to record data. And when the experiment is done, okay, you can save that, and then you have the manually recorded data in those tables. And then it comes to evaluation. And now I switch to the Jupyter notebook, which I have prepared. And I would like to show you how to access the data, which is stored in that table in a very easy way. And for that, we developed this pyelabdata package, which is a very small package, which just combines eLabFTW's API calls and provide single line access to data in eLabFTW.
Michael, I'll just say that there's 2 minutes left.
Yeah, I see that. Okay, thank you very much. So I will quickly go through this. We import some modules, in particular the pyelabdata module, and then there is one function which you can use to connect to eLabFTW, where you pass the URL and the API key you generate in eLabFTW. You open the experiment you are interested in. So the experiment ID is given here, 3459. And then with a single line get table data, you can read the data from this first table with the print command here. We show the result, and you can see this is a dictionary with the first column, the voltage, and the second column, the current, and then the data which is stored in the table. Then it's quite easy to make a diagram out of that. We use a scatter plot with the voltage on the x-axis, the current on the y-axis. And when you have this diagram and you are happy with that, you also want to upload this to your electronic lab notebook. And this can be done using this upload image from Figure, where you pass this Figure object, a file name, and the description. And when you do this and go back to the experiment, you can see that that you have a new file attached to the entry in eLabFTW with the diagram which we just have created. So for the remaining seconds, let me move through those lines of code. So here in the diagram, you see we have 3 different slopes, which correspond to the measurement ranges of the instrument. We can determine the slopes, which gives us the shunt resistances. And using this create extra field command, we can store those results in eLabFTW as extra fields. And then let's have a look how it looks like. You have already seen the extra fields. So this command created a new section results where the 3 evaluated resistances, including the description, are stored. And then let me just go to the final command here. It's also important to store the evaluation script along with the data, because this describes best how the data was treated. With upload this Jupyter notebook, the Jupyter notebook is stored and then uploaded to eLabFTW, and you can find it along with the attached files here together with the other files. Okay, I will, sorry, I want to jump back here and just summarize with the possibility to store evaluated data in extra fields. You get new opportunities because you can also access all the lab course data. And when you provide a common schema, so a specific name for the extra field, then you can collect all the data from all the groups in the lab course. And for example, you can monitor the experiments and see, okay, everyone has gotten 10 kilo ohms except one group. Something must be wrong here. Or you can develop data-driven experiments in the lab course, which are actually not possible when you don't collect the data electronically. And last but not least, we experienced that using the ELN, in particular with the Jupyter Notebook stored along with the electronic lab notebook entry enables scientific discussion with students via a forum in our learning management system, where the students can ask very specific questions, and the tutors have the possibility to look into the raw data, into the evaluation script, and so on, and provide very detailed help for the students. And that actually led to a very nice and fruitful scientific discussion with the students via this forum. Okay, with that, thank you very much for your kind attention. I'm happy to take your questions.
Thank you so much, Michael. It seems really amazing. So there are 3 questions. Do you want me to read them out, or because the attendees cannot see these, right?
Yeah.
Okay. So the first one is from Andrew, who says, "It looks great. Just wondering if there are ways to update or change the course content across all students once it's been pushed to the ELN. For example, if something changes mid-course."
Yeah, if something changes mid-course, you can, of course, update the information. The API functionalities allow this. You just have to read back the options, the objects which you want to change, and then you change the data as you want. So if you want to change the main text, that's no problem. You can change the access rights, that's no problem. You can change extra fields. So it's always a good idea to provide very meaningful tags from the beginning, because then it's easy to collect all similar entries in the ELN.
Great. Okay, so the next question is from Conrad, who says, "Is there a specific reason to use dictionaries as the Python data type for tables read from the main text, as opposed to a table-like data structure like a pandas?"
Yeah, that's a good question. There are actually 2 options which I implemented in this pyelabdata. By default, it's a dictionary where you have the columns. I found this quite easy, but you can change this with a small parameter to pandas, for example, to a data frame, and then you get the table data as a pandas data frame, and then you can also do more sophisticated operations on the data.
Then the next one is from Anders, who says, "Perhaps I missed this at the start, but how do you perform cleanup after a course has ended? Since stragglers are not that rare in university courses, in my experience. Do you throw away the old system and start anew in the next term?"
This is a good point. Actually, we ask the students to download, to export their own data and store this along with their documents from their studies. And then we start over with a new team, eLabFTW team for each semester. So it's always a clean team which we create, and then the configuration script creates all the objects inside, the users, the teams. I should not say teams, the groups in the language of eLabFTW, the groups and the experiments and so on. We have not yet deleted the old data, but that will happen for sure. And this is also a reason why we keep each semester in a separate team, because then after some years you can simply delete the whole team.
Okay, and then the last question is from Conrad, who says, "Will the upload this notebook command upload just the code or the Jupyter output as well?"
So I didn't get exactly the point.
Okay, so what I'm aiming at is that in a Jupyter Notebook you can create new output like graphs, or you can create new data that you've calculated from the old one, stuff like that, and that's usually stored within the notebook, making it rather big if you have some stuff. Does it upload this entirety, or does it just upload the Python code, and if you want the output you have to rerun it?
No, it also it actually stores the whole notebook. So whatever output you generate, this is stored. What happens in the background is that this upload this notebook comment saves the current notebook to the hard drive. So it actually mimics the user action save this notebook, retrieves the file name and uploads that to eLabFTW.
Thank you very much.
Sure, you're welcome.
And there's one more here that has a few parts. Guillaume says, thank you for this presentation. I have a few questions. One, how do you create the user API key? Is it with your starting script? Two, are the Jupyter scripts stored within eLab? How can it be displayed there? And three, does your script read the data in the ELN or is it only written?
Okay, not sure if I will remember all the questions, but let's start with the API key. So the way you do it, or we tell the students to do it, is to create an API key as usual in eLabFTW. You copy paste it into .env file, which is not it is in that directory, but it's not displayed here. And then we use the package .env with .env values to read this .env file. And the API key is then stored in that in the config variable. So that's initially I did it in a very simple way. I just pasted the API key into the notebook, but then it turned out that of course all the users, the students do it the same way, and then we have all the API keys in the eLabFTW. The tutors can see the API keys of all students. Okay, that's not really a damage, but the students should learn how to do it in a correct way. And the correct way is not to store any credentials, secret credentials, visibly in the notebook. So therefore, now we put it in this .env file and read it from there. So what was the second question? I forgot.
The second one was, are the Jupyter scripts stored within eLab and how can they be displayed there?
Okay, so they are stored in eLabFTW as attached file. Currently, I don't know how to display it there.
Yeah, I can answer that. It's something that has been asked repeatedly, but I don't see a way to be able to read Jupyter Notebook without importing the whole Jupyter Notebook ecosystem into eLab. So I think it's much better that Jupyter Notebooks do what they do well, which are Jupyter Notebooks and what Michael showed us, but eLab can keep a trace of these files. And there is something called Jupyter Hub, which would maybe allow, maybe we could have a button on this IPy notebook files to open it into a Jupyter Hub hosted Jupyter, basically. It's like this. So this might be improved in the future, but for the moment, no, there is no way to look at a Jupyter notebook.
Yeah. So the way we do it currently, when students ask a question, so in my Jupyter Notebook evaluation, something doesn't work, what is wrong? Then we simply download the Jupyter Notebook from the ELN entry of the student and open it in Jupyter Lab. It's just 2 clicks more, but not too difficult. And since our own .env file contains an API key, which is a master key, because tutors and organizers have more rights, of course, and the rights to see everything, you can run the Jupyter Notebook right out of the box as you have downloaded it.
Great. Okay, the very last one is, does your script read the data in the ELN or is it only writing? I guess it means, is it only writing data?
So the script it's two bidirectional. You can read the data in either in the way I've shown with the get table data, where you can retrieve manually recorded data from the main text. You can read extra fields which are stored, or you can read files which are attached to experiments. And there's a special command, get file CSV data, where you just have to give the file name, and if the file is CSV data, it already gives you the data which you can use. So therefore, there are several possibilities to read data, and obviously you can store data also by creating extra fields or uploading files.
Great. There are lots of questions. I'm not sure how we feel about time. What do you think, Nico?
Yeah, no, let's move on. And Michael, you can probably answer the questions in the chat.
Yeah.
Because you can see the questions if you click the Q&A icon, and you can probably also answer them directly.
Okay, I will have a look.
Thanks so much for your presentation.
Sure, thank you very much.
So next we're going to hear from Nico, who's going to talk about the API, a hot topic for everybody.
Yeah. And so in fact, Michael's presentation was really a good example of building a workflow on top of the existing eLab API by creating a custom tool that fits their business need. This presentation is really just to get started with the API, to understand what it is, to understand some main concepts. If you are a developer and you already know what is an API and you already developed a Python library, you will get bored. But if you're just interested in knowing a bit more, what exactly are we talking about, and how can I, as a beginner, start using it, then this is the good place for you. So let's go. What is an API? eLab API, using the doc, using Python. So what is an API? Because I guess we first need to define the term. So the French people in the attendance, we will get the reference. So we often hear the term REST API. So I just wanted to introduce the REST term quickly. So representational state transfer. But basically, one point is that there is a client and server architecture. So you are the client, and the eLab instance is the server. There is stateless client-server communication. So if you send two requests, they can be separated by 1 second or 1 billion years, is the same for the server. It doesn't care. It doesn't store anything in between the requests. So every request is its own world. And it has a uniform interface. In our case, it's HTTP. Also, you can just forget everything because we don't care really about REST. What we care about is API. Is really this word that we see everywhere and that everyone talks about all the time. And I think this little cartoon from Postman is very good because it uses the analogy of being at a restaurant. And so you are the customer, so you are the client, you are sitting at your table, and you are requesting from the server, which is the API, something like you want some vegan burger. And so you do a request, hello, I want a vegan burger. And then the API will discuss with the API server. So in that case, the PHP MySQL backend of eLab, that's the cook. And then he gives the burger, and the server answers you. And so what we can define as an API is a contract, like a set of definition and protocols between you, the client, and the server to discuss, like how can we talk to each other. And so basically, you can think of it as a way to perform operations. And I will be using this CRED acronym to create, read, update, and delete from a computer program rather than with your keyboard and mouse. So you might still wondering, like, but why? I mean, I'm not totally convinced. And now maybe that you saw the presentation from Michael, you're maybe more convinced about the utility of it and what you can build with it. But to me, it basically allows you to have total control, or not total, but to increase a lot the control that you can get on an eLab instance without having the need for the functionality to be implemented directly in the web user interface. So as Michael showed, you implement your own logic, your own workflows, your own process. eLab doesn't have a function to upload a Python notebook, but you can create a function to upload a Python notebook exactly how you want it by just writing a bit more code and leveraging basically the eLab API to achieve what you want to do with your eLab instance. So eLab APIs is something that you can access directly if you type /API/v2 in your browser. So it can work in the browser directly, only with the GET request. And you have several tools that you can use. The most common one for first approach of an API would be with the command line tool called curl, which I think is available also in Windows, or at least you can install. I don't know if it's there by default. And anything that is able to make a HTTP request. So basically, all programming languages can do a HTTP request, JavaScript, Go, PHP, of course, everything, Python. Most of the time, you will encounter things in Python, like the library that was presented just before, because Python is just very easy to get to, very easy to work with, and it's very complete. So why not Python? I mean, but also we've seen some R or MATLAB or Ruby programs or LabVIEW also, anything. So one concept to understand is that we use the HTTP interface. So HTTP is the protocol that powers the web since the late 80s or something like that. And this protocol has some verbs. The verbs are the methods that we use to do stuff. When you access a web page, you make a GET request. So you ask the server, I want to get this page. And the server gives you some HTML and the browser presents you this response as a nice page. When you want to create something in the API, you will use a POST request. And when you want to update something, you will use a patch request. And to delete, obviously, you use the delete verb. Let's get to it with a very naive first request. So I just learned that I can access the API by using /API/v2. So I will use curl to make a request to my eLab server. In this case, the eLab server is just named eLabFTW, but probably it will be elab.university.de. And here I'm doing a GET request to the API/v2 address, and the server answers me in HTTP with a status code 401, and it tells me that the content is in JSON. So several things to learn from that. First is that everything happens in JSON. So the way that we represent data on the wire will be JSON. So JSON looks like this. If you don't know what it is, it's a way to encode data in a machine and human readable way. It's ubiquitous in the internet nowadays. It has replaced the XML. So in the response, we can see three different parts. The first one is the repeat of the status code. It's not necessary. Don't remember why I put it there, but why not? One is a message, and another is a longer message to really tell you what went wrong. And HTTP codes are a way for the software, for the API, to communicate the result of an operation. So there are several codes, and you can look them up on Wikipedia by googling HTTP codes, and you will see all the codes that exist. But just to get an idea, when you get 200 is good. 201 is when you have created a resource. So the resource has been created, but there is nothing to reply. There is nothing more to say than sending back the location in a response header. So the response is empty. 400 something means there is an error in your request, and 500 something means there is a bug somewhere and you need to open an issue because it shouldn't happen, basically. But it happens, of course. So what this tells us is that we need to be authenticated. So key point, eLab API needs an authentication. You cannot access it without a key. You cannot access it as an anonymous user. So you need an account on the instance. You need this account to be validated. And then you can create your API key. To do that, the easiest, of course, is to go to your settings page on the API keys tab and to create a key. You can select if you want read-only key or read and write access for this key, and it will show you the key here that you can copy, paste, and store it safely somewhere in your password manager, for instance, so that you can then use it. Now we are going to do the same request, but this time we add the key here in a request header, so with the flag -h in curl. So header is really I don't know how to define. It's not the data by itself. It's some sort of metadata of the request. And so we add an authorization header. We say, okay, look, I have this key, so authorize me. And the answer changed slightly. Before it was 401, now it's 400. And it says bad request, invalid endpoint, and then it lists all the available endpoints. I have truncated the answer here because it's a bit long, but it will tell you if there is an issue, it will try its best to tell you what you did wrong and what you could be doing instead. If you made a typo, for instance, in a parameter, or if you're just reaching an invalid endpoint. So just to show you also here, there's a lot of pixels in this image. So here I used my browser to directly access the API, and I'm using this /info endpoint, which gives me some information about the instance. And so I can access this endpoint by simply browsing to /API/v2/info. You can try it out in your instance. You can just type /API/v2/info in the URL bar, and you will get this response in JSON. It looks better in Firefox rather than Chrome, because Firefox will do some pretty printing of the JSON. Just to come back also on the status code, the status code are the same that you will find everywhere else in the web. So if a resource is not found, for instance, if you want to get the experiment with the ID 43910, which doesn't exist in this example, it will reply with the status code 404, a well-known status code to indicate that the resource was not found. So as much as possible, we try to stick in the design of the API to the true HTTP REST design interface as much as we can. Something to consider also is that the browser uses the API. So I'm going to show you this. For instance, if I want to make a PDF, what I can do is go there and click PDF. Okay, I want to export as PDF. It tells me, okay, do you want a changelog? Or do you want it to be in PDFA or not? And do you want to add a confidential note on it or whatever? And when I click export, what it does, in fact, you see, is just redirecting ourselves to this API slash v2 slash experiment slash the ID of the experiment. And then the rest is what we call query parameters, which are key values. And so one of these key is the format in which I want my PDF and then some other options. And so if we go back to our PDF, what I can say, for instance, is that instead of a PDF, I want to have a CSV or maybe a QR PNG, QR code. And so you see, by editing the URL, I get what I want directly here. But the important aspect is how can I know what are the different formats that I have access to and how can I create queries like this? So one way is to copy what the browser is doing because it's the same interface, it's using the same API, so you can do that. And the other way is to look at the documentation to understand what you can access. So this documentation, in this case here, I'm showing you my local instance that will interact with the local dev server, but you get access to it by going to doc.elab.net/API and selecting here version 2 documentation. And so as you can see, the URL is /API/v2. So it's basically the same URL as the real API. So this documentation describes all the endpoints that exist, and it's generated automatically based on this file, which describes all the requests and response, and you see there is a lot of it, all the requests and response that you can get with the application. And this is what we call endpoints. It's what you put after v2. You put an endpoint and then you put maybe some other parameters behind it. I also forgot to mention that it's called v2 because it's version 2. At some point there will probably be a version 3 and it will use /v3. And this allows us to continue having the v2 stuff work because it will always use the URL /v2, so it's a versioned URL, while we move forward with the v3. If we look at this thing, and we will take here the experiments as example, we can look at the different actions that we can make for experiments. So if we want to create an experiment, we will make a post request to /experiments. If we want to read all the experiments that are accessible, it will be a GET request. And if you want to read one experiment, it will be a GET request to /experiment/ID. And this is actually what happens when you export as JSON. You see, it is simply using the API and simply requesting the /experiment/ the ID of the experiment. And then you have all the data in a JSON file format that is present in the response. So our experiment, so yeah, all the API endpoints are present here. And so with this thing, we can play with it by clicking. So here, this will not work if you use the official documentation. It works only locally, or if you have configured the full thing correctly. So I'm typing this key here that is the one that is present for development, and I will authorize this web page basically to create request on my behalf because I gave it a key. So just to show you, we will create an experiment. Word of caution, what I'm showing you here now is the updated API definition. So you will have only template and tags currently. Even if the rest works, it won't work through the eLab Python API because it is automatically generated based on the YAML. And currently it's missing these new things that has been added recently. Anyway, this shows us the parameters that we can send when we send a post request, we say, okay, I want to create an experiment. So I will send a request, a post request to /experiment. And it tells us that one of the response that it can give will be with the status code 201. It's a successful response. And in the headers, there will be a location, which will be a URL to the experiment that was created. So let's try it out. I will create a new experiment. This body will be the main text content, okay? For the category, I will just put one because I'm sure it exists, and same for the status. The metadata will leave empty for now, but I can put some JSON in there. The title, I will put demo API community meeting. And the tags, I can put tag and another tag. Yeah, I think yeah, that would work. So I click execute, and it shows me the equivalent request with curl. So if I were to do this request with curl, for instance, in a script, I would copy and paste this and it would work. We do this request here, and the response is 201. So it means the experiment has been created. And as you can see, it gives us the URL to the new experiment that has been created. And so now I'm copying this URL and I'm pasting it into my my thing here. In fact, we can use the web interface. And as you can see, we have a new experiment with the category that has the ID 1, with the status that has the ID 1, with our two tags that we added during the creation, and we have the correct title and we have the correct content. And if I were to add some JSON in the metadata, we could have the extra fields, etc., etc. So what we did is very simply create an experiment automatically by using this tool as some sort of helper. But once you understand exactly what are the different verbs, endpoint, and parameters that you can send, you will very easily find what you can do with all this. For an existing experiment, we can use a patch entry, a patch request, sorry. So this one is number 1542. So I will put here 1542. And I will make a request where I will change the title and I will set a new title. And I click execute and it tells me authorization required. Did it forget about the... Oh yeah, it forget about it. Okay. So I'm reauthorizing. Maybe it was another tab. Maybe I missed the tab. So set a new title, execute. And this time, it replies with code 200, meaning all good, and actual content. So basically, when you patch something, it replies with the representation of this resource in JSON. So it replies with the updated version of what you would get if you would do a GET request. So if we do a GET request with this ID here, the 1542, we would have the same thing as below after our patch request. So all the representation basically of this resource. And so patch requests are really something to update an existing experiment, and it also allows you to do some different actions. So the default action, if you not mention an action, will be to update some fields. But if you want to timestamp something through the API, you can use the action timestamp. So I can show you, we can try it out. So what I will do is I will send a patch request and I will say action timestamp. And then I click execute. It replies with the same 200, everything went well. And so now if I look at my experiment, I can see that it has been timestamped. And so everything is described inside this documentation, and you have all the different fields. So it's not perfect because here it's showing all the fields and you cannot modify all of them. So I will have to change the definition so that it only shows the fields that you can modify. For instance, you cannot modify the field timestamp, timestamp by, timestamp at. There are things that you cannot modify. So it's always a work in progress, but anyway, it works good enough for you to get started with it. And we have several endpoints, and as you can see, basically all the operations that the web interface can do, you can do through the API because the web interface uses the API. It uses the same endpoint, the same request. So when you click a button in eLab, what it actually does under the hood is to make a request to the API. So we can do import, we can do export, we can deal with the links, with the commands, the events, the scheduler, we can get everything, the tags, the categories, the status. You see a lot of different things that you can do with the API. So documentation is really important to know a bit what happens. And of course, as always, if you have a question, feel free to join us into this community room on the chat, and we will be happy to help you out with some issue that you might have with the API. Do I have some more slides in my presentation? Yeah, okay, after we go to Python. So then now we know how, so what we learned so far is the different verbs, what they correspond to, and the different endpoints and the different options and how to find these different options to make a request. Then if you want to use a tool that is a bit more evolved than simply making curl requests directly, you can use eLabAPI Python, which is a Python library automatically generated from the YAML file, the specification, from the OpenAPI specification that exists in eLab source code. This Python library, which has been updated 2 hours ago, will allow you to basically do everything that I showed you through some Pythonic objects. And if we want to just look at the example, so what I would recommend really is to learn by example. So there is 16 files here that are even more because it starts at 0. There is 17 files here that shows you how to do some stuff, and they are heavily commented. And so it explained to you. So this is the key. This is the configuration that we use. That's the end of the configuration. And then what do? We want to read items. So items are resources, is the old term for resources and the term that you will find in the API for resources. And so what we do is we ask the Python library to give us the items API object. And with that, we do read items. So basically, read items means /get. It's a get request to /items. And then we can print it as a Python list, and we can add some parameters to that call, like the limit on the number of results or the category filter that we would like maybe to add so that we can only get, I don't know, only the plasmids maybe. And you can also have a raw JSON. One that could be interesting to look at is when you want to import a CSV. You can look at this example script, which shows you with this antibodies.csv example file how to import it in a way where all the columns will correspond to an extra field. So it starts here. We open the file. Okay, so Python, super easy, open as CSV file. We read it, okay, and then for each row, we do something with it. And so in that case, what we do, we create an item. So we use the post item here to create something with the category and the tags. And then we look where this item exists now in the response. So it's the location header that we saw before. We grab the ID from this, and then we patch this existing ID with some more information, such as the body, the custom ID, and the metadata. And so for that, there is here some function to convert some known column names, because generally you know what are the names of your columns. And you can say, okay, so if the column name is name or comment or ID, do nothing, because we don't import them as metadata. But if it's a URL, you make the metadata extra field as a URL. If the column name is price, you make it as a number. And if it is a concentration, you create an extra field of type number with different units, milligram per ml or microgram per ml. And yeah, so basically, yeah, this is just an example. You look at it, you try to adapt it with your CSV, and it results in your CSV being imported exactly how you want it, because you put everything exactly how you want it. So feel free to have a look at this. And also, I want to mention that on the README of the eLab main project, you can find here a link to some other projects. So pyelabdata that was just presented is present here. eLAPI, which has been presented at the past meeting, is present here, and I saw the developer in the room. And you have also other projects which could be interesting for your use case, and some other unofficial documentation from some other entities. So feel free to explore. We also have an example with JavaScript in case you want to make a web application that discuss with eLab application. You can do that also, but this needs some configuration on the eLab server side to accept requests in the browser directly. And with that, I think I will stop here, because this is really what I wanted to show you. Explain the concepts, the basics, how you can get to it, point you to the documentation and to the library, show you some light examples so that everyone has a good understanding for it. And yeah. And so then, if you want like a real workshop for your institution, contact us. We will be happy to give you a more complete workshop, and maybe something that fits exactly what you need, because you might have some very specific needs. Okay.
Thanks, Nico. So if we're trying to end at quarter after, we just have about 7 minutes left. So let's do some questions. You want to take that first one?
Yeah, so thank you, Anders. In fact, I wanted to mention that you're very, very correct on that. If you press F12 and you look at the network tab, you will see all the requests that it makes. And this way you can understand a bit how the application is doing the work, and you can simply copy it for yourself.
It's great seeing an example of such a like carefully designed API system, and then getting to learn some of the basics of it. I guess if there's no more questions, there's one more thing I can say, which is that I'm starting a new project that's focused on learning about the research conducted by our users and their day-to-day activities. And I'm planning to conduct some mini interviews that will be shared with the community and publicly on our social media. So the goal of this project is to just help people understand like what researchers do in the lab and give people a chance to share like what their workflow is like. So if you're interested in having a short conversation with me, you can send me an email at sydney@deltablot.email, or you can post your email in the chat. If you can. I think maybe you have to put it as a question. And then also there's a bunch of links for us on social media. No pressure to follow, but there they are. I'm just going to send those to Nico so that you can post them in the chat. And our next community meeting will be in about 2 months. We're still figuring out the date, but we already have some presenters who are excited to speak with us then. And we'll send out all the emails and stuff about that. Oh, I see one question from Andrew here. It says, probably missed this, but are the API keys working at a group level / user level and with the permissions of the group / user? Oh, I can't hear you, Nico.
Yeah.
Mhm.
And an API key is bound to a user in a team. So with a given API key, if your user is part of several teams, you will interact with that particular team because an API key is created with this couple user team and it has the exact same permission than the user itself.
Cool. Thanks for that answer. Okay, well, so now you've got all of our social media. I know a lot of science people are moving on to Blue Sky, so it's kind of an interesting space right now. If there's any other places that you think it would be cool for us to be visible, please let us know because I can see that the sort of social media landscape is changing a lot right now, and I think we're interested in experimenting with like newer options. But like we're on Mastodon, for example, and that's been cool. Yeah, anything else you want to say, Nico, before we close the meeting?
Yeah, maybe just want to mention that the Mastodon account is the
Mm,
poet.chapril.org because it might not be evident from the URL that
true.
this is Mastodon.
Yeah.
And yeah, thank you everyone for joining. This video will be available on YouTube so that you can watch it during Christmas holidays with your family. Yeah, I guess if there are no more questions, we can stop here. I want to thank Michael again for his presentation and Sydney for hosting this. And yeah, that's it. Let's stop here.
Okay, thanks everyone. Have a nice rest of
Bye.
your
Have a
day.
great afternoon, night, whatever. Bye.
Okay,
Thank you, everyone.
bye.
Bye bye.